Good morning to all. Our today's topic is current electricity. This topic is of class 12 science, subject physics. The first in this is electric current. What is electric current? Electric current is the charge flowing through any section of the conductor in 1 second. Now, here we have considered a conductor. This is the conductor, and we have considered a section of the conductor. This arrows are showing the conductor section of the conductor, any section. These are the electrons. Now this is the negative terminal, this is the positive terminal. Now here positive and negative, these both the sides produce electric field in the conductor, inside the conductor. So this electric field is always from positive end to the negative end. Now this will be from positive end to the negative end. So electrons are always drifted from negative side to the positive side. So it is always the motion of the electrons is always opposite to the electric field. Now these are flowing, these are attracted towards the positive terminal of the conductor. Now these electrons have negative charge and this side is positively charged, so they attract each other and all the electrons are attracted towards the positive end of the conductor. Now here the number of electrons passing through this cross section of the conductor, this section of the conductor, in 1 second. I am again repeating, the number of electrons passing through this section in 1 second is known as electric current. Since the number of electrons flows per unit time is known as the electric current, the formula for electric current is I is equal to Q upon T, where Q is charge and T is time. If the rate of flow of charge is steady, if the rate of flow of charge is varies with the time, then the formula is modified to this, that is I is equal to dq upon dt, where dq is change in the charge and dt is the change in the time. Now SI unit of electric current is ampere. There are different types of current. One is steady current, varying current, and third one is the alternating current. The steady current does not vary its in magnitude with the time. Its magnitude always remains constant with the time. So here is the graph between I that is current, and here there is time. So in x axis the time will vary, in y axis the current will vary. Now this horizontal line, that is A line, this is the A line, the horizontal line shows the steady current. Why it is steady current? Because at the zero time and at the final time the value of current is same, so it is not changing with the time, that's why it is known as steady current. The varying current are those current whose magnitude varies with time. So here curve B and curve C are showing the varying current in the graph. So B curve, here the value of current at time t is equal to 0 the value of current is 0, but after some time its value goes on increasing. So hence its value is not fixed. So this is not the steady current, this is the varying current, and shown by the graph B and the C. Now third one is alternating current. In alternating current, the value of the magnitude of the current varies continuously. So here it is 0, then it increases, then it decreases, then again it goes on increases, then again it decreases, then again it increases. So its value goes on changing continuously, and also once it goes upward, and in the next cycle it goes downward. So this completes one cycle. This is the one cycle from here to here. So half of the cycle it is positive, half of the cycle it is negative, again positive, and again it is negative. So here we can say it changes its direction after a fixed period. After a fixed time interval, it changes its direction. So up to this time it is positive, and after this up to this time it is negative. This is the negative. So it changes its direction also and changes its magnitude also. Here it is written the alternating current whose magnitude varies continuously and direction changes periodically. So these are the types of electric current. Next is conventional current. What is conventional current? Conventional current are those currents whose direction is along the direction of positive charges. So these are the positive charges. Now this is the positive terminal, this is the negative side of the conductor, or we can say terminal. Now here these are the positive charges. Okay, now we know that positive charges are attracted towards the negative side. Positive and negative attract each other, so all the positive charges are attracted towards the negative plate, and since they move from positive to negative side of the conductor, so hence we have defined that the direction of the current will be the direction of the positive charges. So positive charges flow from positive to negative, so current will also flow from the positive to the negative. So this is the conventional current. Here we can also define it in another way, that according to the electrons, the motion of the electron is always opposite to the direction of the flow of current. Means the electrons flows from negative to positive, but the current flows from positive to negative. So electron flow in the positive opposite direction from the electric current. Next is the drift velocity. Now here see in the figure, this is the battery, this is the conductor. The positive side of the battery is connected to the A side, and this negative terminal of the battery is connected to this side of the conductor, this side. Now in the conductor we know that there are number of free electrons. We have studied the free electrons which are responsible for flow of current. So there are number of free electrons available in the conductor. These are not available in the insulator, so they doesn't conduct the electric current. So for flow of electric current we need free electrons, and these are abundant in the conductors. So free electrons here are attracted towards the positive side of the conductor. So these electrons are attracted or drifted, because when we say that this is positive side and then this is the negative side. So electric field always flow from positive end to the negative end. We know that electric field flow from positive end to the negative end. So these electrons are drifted from negative end to the positive end, opposite to the electric field. So these electrons are drifted always opposite to the electric field, so they experience a force in the opposite direction. So they after experience the force, they move towards the positive end of the conductor, and the velocity, the speed with which they flow towards the positive end is known as drift velocity. So we can define also, drift velocity is the velocity with which free electrons get drifted towards the positive terminal under the effect of applied electric field. So here is the formula for electric field. It is minus negative of E upon may m into tau. So here this small e is the charge on one electron, this capital E is the electric field created here, and m is the mass of electron, and tau is the average time of travel of the electron. So here negative sign represent that the direction of flow of electron, that is direction of velocity of electron, is opposite to the direction of electric field. This negative sign represent this. So E is opposite to the Vd. So this is the significance of this electron negative sign. One, there is another formula here, it is written in orange color. I is equal to NEA Vd. So this is the relation between current and drift velocity. Again repeating, I is equal to NEA Vd, where N is number of electron, E is charge on one electron, A is area of conductor, and Vd is the drift velocity. So these are the two formulas. One is for drift velocity and one is relation between I and drift velocity. Next is the current density. Current density, what is this? This is the current flowing through a unit area of the conductor. Inside the conductor, if we consider a unit area, then the current flowing through this area is known as current density. So here also the current per unit area, this is the current density. Also we have studied here this formula, I is equal to NEA Pd. If we put the A and we get the A to the right side to the left side, so it will be like this, I upon may A. So what is left here? Here it is left NE Vd. So here it is NE Vd. So J is equal to I upon A, and I upon A again it is equal to, from the relation of current and drift velocity, it is equal to NE Vd. So this is the current density. Current density means the current flowing through the unit cross sectional area of the conductor. So if we consider this is the complete conductor, okay, this is the complete conductor, and if we consider only unit area of this conductor, 1 unit area, then the current flowing through 1 unit area is known as current density within a conductor, inside the conductor. So the area vector is always perpendicular to the direction of flow of current. Here, if we consider, this is the direction of flow of current. Current flows from positive end to the negative end. So this is the direction of, this is horizontal. Let me show you. This is the direction of flow of current, okay. So now perpendicular to this is this line. So this area is known as, this area is perpendicular to the direction of the current, okay. So we have to consider the area which is perpendicular to the. Now next is Ohm's law. Now here Ohm's law, according to Ohm's law, the potential difference, now here it is connected, conductor is connected to a battery of V volt, and current is flowing from positive terminal to the negative terminal. This is the direction of flow of current. Now when we flow a current through the conductor by using a battery, then the electric current is directly proportional to the potential difference across its two ends. So these are the two ends, and the current flowing this through this conductor is always directly proportional to the potential difference across the ends of this conductor. And the here condition is that the temperature and mechanical strain should be constant or same. Temperature should not change. So here is the mathematical relation. I is directly proportional to V, or V is directly proportional to I. So to remove this directly proportional sign, we use a constant. So we use V is equal to Ri. Here R is constant and it is known as resistance. So here is the graph between I and V. So it is a linear relation between I and V, showing the graph is showing linear relation. So there is a straight line. Next is the carbon resistors. For having a resistance of like 8,000 or 10,000, okay, or more than this, we cannot use the simple wires like copper wires or aluminum wire. So these wires doesn't offer such high resistance. For having such high resistance, we have to use another materials. So for this purpose we use a carbon. A powder of the carbon is modified into the small pieces having shape of refill of the pen, having size of the refill of the pen. They are just like the that size and that shape, cylindrical shape, and the size of refill of the pen. And both the sides they have metal coating. They have metal coating, and this is the wire for connecting it to the circuit. So here on both the ends we have metal caps, and this is the wire. And now Color coding for carbon resistors. Color coding, what does it mean? That if we want it to sell to the international market, we have to use a international standard symbol for specification of the conductor of the carbon resistor. For specifying the resistance of the resistor, we cannot use the local words like ohm, or we cannot use the local symbols which we use in our country, because the symbols or the letters we are using for indicating the resistance, we cannot say that these are also used in the another country to which we are selling this carbon resistor. So for providing a standard dimensions, for providing a standard specifications, we have to use some color codes. So these are the color code. We make 3 bands on the carbon resistor on one side. These are the 3 bands. Okay, these are the 3 bands. So these 3 bands, what does it shows? These 3 bands shows the value of the resistance. Now here, if we see that this first band shows the first letter of the resistance. So this one is shown by the B first band of the carbon color coding. Second band of the carbon color coding shows the second letter of the resistance specifications into 10 to raise power. Again, this 10 to raise power is shown by the third band. Now here we have given the example BVB. Now these colors are the specifications for the value of the resistance. For example, black shows 0 resistance, brown shows 1 number, red shows 2 number, orange shows 3 number, and likewise we have number of colors for showing the number of digits. Now here BVB, the first B is for brown. First brown B having value 1, so here we have written the first letter 1. Second color band is V, means violet, and having value of 7, so we have written the second number 7. Now the raise power for 10, for specifying the raise power of 10, we have to see the third band. Third band is B for black. So 10 to raise power is 0, means black. So likewise we have the fourth band also on the right side of the right end of the resistor. So here we have 3 types of bands. If we have gold color band, then the tolerance is 5%. If the color of the band is silver, then it has tolerance 10%. And if there is no color, as shown in this figure, there is no color band on this side, then it has tolerance of 20%. What does tolerance means? Tolerance means the purification of the carbon material which is used for the making this resistor. So this resistor, as we know, made up of carbon. The level up to which it is purified, it is specified by the tolerance level. So 5% tolerance level means the most purified form of the carbon, 10% means medium purified, and the 20% means the minimum purified carbon. So the rate of the resistor is also depend upon this tolerance level. If there is gold, then it is very good carbon resistor, and its price will be higher, and for this no color or silver, the price will be lower than the gold. So likewise we can specify the resistance of the carbon resistors. Now we have learned the carbon resistor, its use, why these are used. These are used for having a resistance of higher values like 10 to raise power 3, 4, 5. So now we have also 3 examples here. The first one band here is G means green, and for green the value has 5. So we have written first letter 5. Second letter here 2 is specified by the second band, which is red, and for red it is value is 2. So this list or this color coding can also be remembered by a formula or by a cramming rule, that B.B. Roy of Great Britain has very good wife. So here we have B.B. Roy of Great Britain has very good wife. So this is the formula you can use for learning the value as well as the list of the colors for coding system. This is the color coding for the carbon resistors. Thanks.